In this video, we will learn about friction. We will learn about the difference between the static friction and the kinetic friction, and we will just look over one quick problem to make sure that you understand these concepts. So let's start by examining the difference between the two. So the static friction is the friction when the object is at rest. So when the object is not moving, in other words, as opposed to kinetic friction when is applied when the object is moving. So if you have ever pushed something really heavy and you notice that when you try to push and make it go with a certain velocity, it's really hard. And then once it's already moving, it becomes lighter. What you experience is the transition between the static friction to kinetic friction. Since at first it's always more difficult, right? The static friction is always greater than the kinetic friction. Now, the kinetic friction is equal always to the formula of mu times n. So kinetic friction, mu is basically coefficient of friction. So you can think about it as roughness of the surface, right? For example, ground will have a greater coefficient of friction than ice that is pretty smooth. So mu will most of the time will be given in the problems, and n is the normal force. The static friction has a similar formula, but there is one little caveat. The static friction is also mu times n, but this coefficient right here is the coefficient of static friction, which is usually a little bit greater than coefficient of kinetic friction. And n is still normal force, of course. However, the caveat is in the fact that this force represents the maximum static friction, right? So this is the friction that you need to overcome in order to make the object move. So the static friction force is less than or equal to this. Why? Well, let's say, for example, you're pushing with, let's say, maximum static friction, you calculate it is 10 newtons. That is, you need to apply a force of 10 newtons in order to make this box move. But let's say you apply a force of 5 newtons, right? And the box doesn't move because you didn't apply enough force. Well, it doesn't really make sense to would have said that the static friction force is 10 newtons because that would imply that the box starts moving to the left, right? Instead, what's going to happen if you apply the force of 5 newtons and the box fails to move, the static friction in the other direction will be also 5 newtons. So the static friction, you can say, is always equal to the applied force up until you essentially overcome the static friction, right? So if I apply a force of 3 newtons, let's say, my static friction will also be 3 newtons, etc., etc. So now let's take a look at a really quick practice problem to see how this concept applies. So if the coefficient of friction between the box and the surface is, so a static friction will be 0.45. The kinetic friction will be 0.12. And the max mass of the box is 2 kilograms. So just like with the other problems, we can assume that this is on a horizontal surface, right? That you apply, let's say, the force to the right, and there's the friction to the left, right? There's a normal force upward, and there's a gravitational force downward. So we can assume that the normal force is equal to mg, right? So up force is equal to the down force. Great. So will the force of 5 newtons be enough to make the box move? Well, of course, what we have to calculate here is the maximum static friction force, so mu s times n. As we've seen from this picture, right, since it's on the horizontal surface, the normal force is just going to be equal to mg. So mu s is 0.45. Mass of this box is 2 kilograms times, let me take g as 10. So the answer will be 9 newtons, right? So is the force of 5 newtons enough? Well, no, it isn't, right? Because 5 newtons is less than 9. So therefore, no, it's not enough. So my question is then, if the force applied is 5 newtons, what is the static friction force, right? Now, hopefully, I want you to think about it for a second. So what do you think? What is the static friction force if our applied force is 5 newtons? So hopefully, you said that the static friction force is equal to 5 newtons as well. Again, because it will just try to cancel out whatever the applied force is. So the static friction is 5 newtons. And we have already answered part C about the minimum force that we need to apply to make the box move, right? If this question was asking additional parts, let's say that we're asking about kinetic friction, right? You can calculate kinetic friction by just plugging in this coefficient. So just like this, we'll learn about the difference between the static friction and the kinetic friction, right? And how the formulas apply in both of them and how to deal with them in these problems. Keep practicing on your way to an A.